Hi guys, welcome back to the channel LeetCode and Sleep, and today's LeetCode problem will be implement queue using stacks. So let us see what are the companies asked this question here, and we can see all the FANG companies have asked this question. So this is a very important question we need to solve here and we need to understand it. Okay, so let us quickly dive into the problem here. So as we can see here, the problem statement is so implement a first in first out FIFO queue using only two stacks here. The implemented queue should support all the functions of a normal queue. Okay, so we need to implement a queue using two stacks here. Okay, so it should also support all the functionalities of queue here. Okay, so now what are all the functionalities we need to implement here? We need to implement the push functionality, pop functionality, peak functionality, and the empty functionality here. So these are the functions and we need to implement here. So let us quickly check how we can implement queue using two stacks here. Okay, so uh, as the question says, we require two stacks here. So I will initialize my stacks in the here, and in the constructor, so the class attributes have two stacks here, right? So the class attributes have two stacks here. So and the constructor has the initialization of the attributes here, right? So I will be initializing the two stacks here in this constructor. So coming to the push functionality, so the two stacks are now, let us see why so what is the first stack and second stack here? The first stack will be the main stack here. Okay, that will be the main stack, and the second stack will be the auxiliary stack. Okay, that will be the using for uh, that will be using for many purposes. Okay, and this is the S1 is the main stack and S2 is the auxiliary stack here. Okay, so let us quickly implement the push function here. So before pushing uh, before pushing, so let us visualize what is a queue here. Okay, a queue is a data structure which stores the different types of data, right? So uh, so so we can add elements from so in a queue data structure, it has two openings. Okay, first from the first and from the last. Okay, so whatever the element we need to push, we will be pushing it from the last here, and whatever the element we will be so if we consider this as a starting and this as an ending, so whatever the element we need to push it from the last here. Okay, so if at all we need to push 6 here, we need to push it from the last year. So this is the functionality of queue here. Okay, so this is the functionality of queue data structure, and whatever the element we need to pop it out. So we need whenever we need to remove one element from queue, we will be removing from the starting here. So from starting we will be removing, and from last we will be pushing it. So this is the functionalities of stack here. Okay, functionalities of queue here. So let us visualize what is stack here. What are the functionalities of stack? So whatever the so it will be in the stack there will be only one opening here. Okay, it will be from the last. Okay, so whatever the element we need to push, we will be pushing it from the last only, and whatever the element we need to remove, we will be removing it from last only. Okay, so whatever the element we need to remove and whatever the element we need to push, it will be removed from last only, right? So there is as there is a only one opening, so we need to implement these queue function using two stacks here. Okay, so we need to implement queue data structure using two data structures that are stacks here. Okay, so now let us quickly see how we can implement push function here. So what is push function in what is push function in queue here? Push function is pushing the element from the last. So in the queue also we will be pushing the element from the last, and in the stack also we will be pushing it from the last only, right? So the push functionality will be same for stack and queue here. So I'll be pushing my elements into my main stack here. Okay, that will be S1. So I will directly push into my S1 main stack here. So now let us quickly understand how we can implement pop function here. So now to implement pop function, So in queue data structure, what is pop? We can what is pop? The remove function, right? So at what from where we can remove the element? From the starting, right? But in queue, where we can remove? From the last, right? So as so for removing the first element in the queue data structure, we will be removing directly this ring, right? So but removing one element in the stack data structure, we need to remove 6, 5, 4, 3, 2, 1, right? So we need to remove all the elements from the stack, right, to remove the first element of the stack, right? So but in the queue, we can only we can directly remove it from the first opening, right? So uh, by using stacks, how we can implement the pop function here? So here what I will do is I'll be transferring my all the elements to my auxiliary stack here. Okay, so uh, so I'll be transferring my all the elements from my main function to main stack to auxiliary stack. So my auxiliary stack looks like in this way, right? So now from my auxiliary stack, whatever the element I pop it out, it will be the first element of the main stack, right? Right. So now we can pop it out, right? So now we can pop it out the first element. So in this way, I will be implementing my pop function, right? So now let us quickly observe the code here. So what am I doing? I'm first of all transferring all the elements from main function to auxiliary function, right? Auxiliary stack here. So this is the while loop for transferring all elements from main to auxiliary here. And whatever the last element will be, the last element in the auxiliary stack, that will be the first element, right? So I'll be popping out and I'll be storing it in a variable, right? Now after doing this operation, what I need to do, I need to again transfer my all elements from my auxiliary stack to main stack here. So now I'll be transferring all the auxiliary elements to the main stack. So I'll be again transferring my this is a while loop for transferring all the elements from auxiliary to main stack here. So this is, and at last I will be returning a here, which is the starting element, right? So in this way I will be applying the pop operation here. So and peak operation is also same as pop operation, but here we will be removing it from the data structure, but we will be just getting the last element, right? Getting the last element here. So in the pop also, what we are doing, we were transferring. So in queue, what will be the peak here? That will be the starting element, right? So for getting the starting element in stack, what we need to do, we need to transfer it to auxiliary, and whatever the last element of auxiliary, that will be the starting element of main, right? So in this way we can get the starting element of stack, right? So the same functionality of pop, we will be transferring all the main elements to auxiliary, and from auxiliary we need to find the peak here. So in stack, what will be the peak? That will be the last element, right? So it will be the last element, which will be the first element of queue here, right? And after finding the peak, we need to transfer all the auxiliary elements to main stack here. So I'll be transferring all the auxiliary elements to main stack here. So this is how I'll be performing the peak operation here. And the last thing is empty operation, empty functionality. So what is empty? Whether we need to check our queue is empty or not. In queue data structure, what is empty? Whether it is empty, whether it has elements or it has no elements. So in stack also we have same kind of data structure, like that is main stack, right? So we'll check whether our main stack is empty or not, right? So same functionality. So whether it is empty, then it will return true. If it is empty, whether it is not empty, then it will return false here, right? Same. And coming to the time complexities of these functionalities, so for stack it will be obviously big of one constant space, right? Constant time complexity, right? Big of one only for pushing the element into stack. So for pushing the element into the stack, it will be from last only we will be pushing it, right? So it will be big of one only, right? And for popping it out, we need to transfer all the elements from main to auxiliaries, right? So this while loop takes big of n operations, right? So the pop functionality time complexity will be big of n here, okay? And for peak also it will be big of n only, right? As we are transferring all the elements from main to auxiliary, right? So this is also will be big of n operation only. And at last, For checking empty stack, that will be constant time complexity only, right? So for checking whether our queue is empty or not, uh, we need only big of one operation only, right? So, and the space complexity of this problem is, and as we are using two stacks here, so it will be 2 into big of n, and so we can take it to big of n only, right? So the space complexity will be big of n, and overall space time complexity will be big of n here. Okay, so this is how we'll be solving this problem here, like implementing queue data structure using two stacks here. And thank you for watching this video, and subscribe to the channel, and thank you.